Welcome back to Mrs. Bassone's class. Today we are going to learn how to use proportional relationships to find percent change and percent error. You will need a sharpened pencil with an eraser, a calculator, your guided notes sheet, and of course you'll follow along and fill in the spaces as prompted in the video, and of course your headphones. If you're missing any of these items, please pause the video, go retrieve them, and resume the video when you get back. So let's review. What is a proportion? We've been working with proportions for quite some time now, so I know all of you are experts at solving proportions. And a proportion is an equation stating that two ratios are equal. How do you solve a proportion? I know that you know how to solve a proportion. They can be solved using cross multiplication, or like some of us like to call it, the butterfly method. So what is the percent of increase? Well, the percent of increase is the percent that a value increased from the original amount. So you have an original value and it gets larger, so it is increasing. And you see the arrow is pointing up, and that's an increase. The percent of decrease is a percent that a value has decreased from the original amount. So it was larger before. The original amount is larger than the final amount. Finding the percent of change. So this looks familiar. This is a proportion, and I know that we are all used to proportions now. So the percent of change goes on the upper left hand side. This looks very familiar to what we were doing before when we were trying to figure out percents using proportions. 100 goes on the bottom left, just like it always has. And on the right side you have the amount of change on the upper right hand side, and on the lower left hand side you've got the original amount. So let's try to go ahead and solve one of these proportions. And all of this should look familiar as far as how we set up the proportions, but you do have access to these notes for your homework and even for the test. So you can use these to help you remember what goes where. So if the price of a purse increased from $45 to $54, what was the percent of increase? And we can tell without them asking what the percent of increase is that it increased, because we've got two numbers and it says that it was originally $45 and it went to $54. So here we have, we're going to do our cube strategy, of course, like we always do. So we circle the numbers, and that helps me. And then the question is, what was the percent of increase? And I am going to cube in here some of the important words. And believe it or not, from and to are very important, because from indicates that that's what the price was originally, and to indicates that that's what the price is changing to. So that's really important, those words, even though they seem like not very important words, they really are, and they really help us to understand how to solve this problem. So from our original notes, we know that percent change goes on the top of our proportion. 100 goes on the bottom, just like it always has. An equal sign, right? Because this is an equation. And the amount of change, which is going to be, I'll fix that right. All right, $54 minus $45. We learned that we could subtract to get our change amount. And the original amount we already decided was 45. Okay, so now we know that they're asking for the percent of change, so that's actually our variable. So we're going to write our variable of x, our unknown variable, over 100. We know that 54 minus 45 is 9. And then on the bottom we have our original amount, which is 45. Go ahead and solve that. Pause the video, come back, and we will check your answer. So you should have got 20%. Don't forget your percent. It's very important. And that's what you should have. On your guided notes, please show all the steps that you took, the butterfly, and everything that you took to solve that. So what this is essentially telling us is that the price increased by 20%. So it was a 20% increase. Let's do another one. So I'm going to circle my numbers because that's what I always do, and it helps me to know what I'm doing. So I circled my numbers. Percent of decrease, which means the price is getting lower, so the price was higher before. And then finally, I'm going to cube in decreased, obviously, that's really important, from and to. Okay, so let's set up our proportion. We know that we have an equal sign there. So we know that our variable is going to be x, and we know that 100 is going to be there, just like always. So we're going to take 60 minus 36 because that's the step that we have to take, and we know that we have to subtract 36 from 60. And the interesting thing that's different about the percent decrease than percent increase is that now you have a larger number that goes on the bottom because that was the original amount. So go ahead, pause the video, solve this, come back. Okay, so you should have x equals 40%. If you did not get that answer, please raise your hand and either Mr. Wallace or myself will come and help you. So let's talk about the percent of error. Now we know that when we make errors, we are making mistakes, right? So that's some way that we can think about what we're actually solving here and what information we're trying to figure out. So the percent error is the measure of how inaccurate or wrong a measurement is compared to how large the measurement is. So therefore, a smaller percent of error would mean that the measurement was closer to the actual final value than if there was a large percentage of error. So if we have, for example, we have two percentages here, 10% and 50%. We know that 50% is actually larger than 10%. So we would want, if we were actually estimating something, we would want to have a smaller percentage of error, so we would want to be at the 10% rather than the 50% of error. Okay, so finding the percent of error, this is very familiar. We still have here the percent of error on top, so the percent is on the top, and that for the purpose of solving these problems is going to be our variable. And we have 100 underneath, just like we always have. Here you'll take the larger number and you'll subtract the smaller number, and then the exact value. What was the actual real number that you got you know, in the example? So there's an estimate and then there's actually the exact value. What was the actual value? And the percent error will always be a positive number. So let's look at our examples here. Let's use our cube strategy. We've got some numbers here we need to circle, $4.50. Then we have $4. Okay, what is Dennis's percent error? We know that that's going to be our variable. And here we have, okay, so Dennis calculates the amount of the card as $4.50. So the actual price, and I'm going to write the exact price because that's what that means. The exact price of the card is $4. So Dennis says that he's going to buy a card. He says, I think it's going to be about $4.50. And then he goes and purchases the card. And the card actually is only $4. So what we're going to do, we know our percent is going to go on the top. That's our variable. They're asking what the percent is. 100 goes here just like it always does. And here we're going to take the larger number, which is $4.50, right? Because we'd rather have $4.50 than $4. So that's larger, minus $4. And we're going to take that value over the actual amount. So the actual or exact price of the card was $4. So you're going to end up, after you subtract, on the top, that's all you're doing is subtracting $4.50. You're subtracting $4 from $4.50, excuse me. So then you're going to have 0.50. And then that's going to be over 4. So if you can see what I did here, all I did was I subtracted the larger number, or the smaller number from the larger number here, and I put this value on the top, and that is 0.50. So go ahead and solve that and come back and check your answer. I want to see everybody's work. You should have x equals 12.5%. Don't forget your percent. So that means that Dennis was off by about 12.5%. His percent of error was only 12.5%, which is respectable. Okay, so Elena's math class had 24 students yesterday. She miscounted the class total and recorded it as 20 students. What is Elena's percent of error? Okay, so let's use our cube strategy. We know that we have 24 students there, 20 students there. Okay, we know our question. What is the percent of error? And we also know, let's see what we have, miscounted. So we know that's percentage of error. Okay. Okay, so it actually had 24 students. All right, so those are the words that I can see in there that I find are relevant. We know that our variable is the percent of error because that's what we're trying to find. So you have to take the larger number, which is 24, and the smaller number. So you'll take the smaller number from the larger number. She actually had 24 students in the class. So we're going to go ahead and do this math here. We have to transfer our x in 100. So 24 minus 20, you should get 4. And then underneath you will have your 24. And I just dropped all this stuff down here. I did the math, 24 minus 20, and we have that. Go ahead and pause the video and solve this. Come back and check your answer. Okay, you should have x equals, and it's 16.6 repeating. I am going to round to the nearest hundredths, just like we're used to doing. And so I'm rounding it to 16.67%. I don't want to forget my percent sign there. So these are pretty simple as long as you make sure that you are using the right proportion example here. You know your percent's always going to be on the upper left. 100 is going to be on the bottom left. The only new thing that we're doing that's different from what we did before is the subtraction on the upper right. And you'll always do that on the upper right. Okay, so this one is the larger number, subtract the smaller number. Then you divide it by the real number. If you had any difficulty with this, please raise your hand. Mr. Wallace or I will come and help you. So now we're ready to practice. Good job, guys.